Given the function y equals 2x times cosine x, what is the value of dy dx? This is asking you to find the derivative of this guy right here with respect to x. What we have is we have two expressions multiplied together. So I'll call the first one, which is 2x, u, and I'll call the second one v. Now, a lot of people might use f's and g's, but I like u's and v's because I enjoy the sun's harmful rays. Now, this is going to require what's called the product rule. Okay, if I were to label that u and v, the product rule is going to be u prime v plus v prime u. So let's list out the fact that I know what u is, or u are. And if I want to find out what u prime is, I'm going to use the power rule and take the derivative of 2x, which is just regular old 2, no problem there. I called v cosine x. The derivative of cosine x, v prime, is negative sine x. So what I have to do is I have to put this all together, make it look nice and neat. So in this case, dy dx is going to equal u prime v, so 2 times cosine x, no problem so far, plus v prime, which is negative sine x, u, which is 2x. Now that doesn't look so great, so let me take one more step and clean it up. 2 cosine x, let's put plus negative and make that a minus. Let's bring that 2x out front and make u sine x. So the derivative using the product rule of 2x cos x is going to be 2 cos x minus 2x sine x, which is going to be b, baby. So yeah, fun stuff. Hope this helps. Let f of x equals 600x minus 2x cubed. On which of the following intervals is the function f increasing? So if I want to find out when a function is increasing, that means I care about when its derivative is going to be positive. So this is going to be a three-step process. Step number one, take the derivative, set it equal to 0, find the critical points. Step 2, use those critical points and make a sign table. And step 3, plug in some points to find out where things are going to be positive or negative. So let's find our critical points by taking the derivative. F prime of x. Power rule, power rule. The derivative of 600x is 600, easy peasy. Minus the derivative of 2x cubed is 6x squared. Now to find our critical points, what we do is we set this equal to 0. Critical points mean that we have a place where something changes from positive to negative, or increasing to decreasing, or vice versa, decreasing to increasing. So we care about this. Let's add 6x squared to both sides, like so, cross you out. 6x squared is going to equal 600. Divide both sides by 6, like so. X squared is going to equal 100. And in order to get x all by itself, we positive or negative square root both sides, giving us critical points at positive or negative 10. So here's my critical points. Now what I want to do is I want to make myself a sign table. So a sign table for f prime of x. All right. So I have two critical points. They were at negative 10 and positive 10. What I need to do is I need to choose 3 numbers on intervals here that are not negative 10 or positive 10. So what I want to do is I want to plug numbers in to see if it's positive or negative on that interval. I want to plug it into the derivative function. So I'll choose 0 because 0 is a nice number living in between negative 10 and 10. I'll choose negative 100 because why not, and positive 100 because you can't tell me what to do. Now what I have to do is I have to take turns plugging these 3 numbers into the derivative. If when I plug it in, I get a negative number, that means it's decreasing on that interval. And if when I plug it in, I get a positive number, that means it's increasing on that interval. So let's start out with f prime of negative 100. That's going to be 600 minus 6 times negative 100 squared. 600 minus, now let's do a little bit of quick math, negative 100 squared is 10,000. Negative 6 times 10,000 is negative 60,000. I don't care what the number is. I just care about the fact that this is negative. So since I get a negative number here, What that means is f prime, or f regular, the function, is going to be decreasing from negative infinity all the way up to negative 10. That's what this means. A negative derivative implies that the function is decreasing on that point on that interval. So let's do it again, and let's do it with 0. F prime of 0 is going to be 600 minus 6 times 0 squared, which is going to be 600 minus 0, which is going to be a positive number. So you're positive right here, which means my function is increasing between negative 10 and positive 10. Now let's just be on the safe side, make sure we get something that we want here. Okay, we'll plug in 100. So f prime of 100 is going to be 600 minus 6 times 100 squared. And what's going to happen is the same thing that we had up here in blue, or if you're colorblind, gray, and we get 600 minus 60,000, which is negative. So we are negative right here, which means that we are decreasing on the interval from 10 to infinity. So the only spot where it is increasing is where the derivative is positive, and that happens between negative 10 and positive 10, not including those numbers, because including those numbers would be saying, sure, the slope is 0, which means that's not true at all. It's neither increasing nor decreasing. So the answer to this guy right here is a lovely old B. So fun stuff. Hope this helps. What is the antiderivative of secant squared x with respect to x? Well, antiderivative is just fancy talk for integral. So this is asking for the integral of secant squared x dx. And this is just flat out memorization. Okay, hopefully you remember from the regular derivative parts that the derivative of tangent is secant squared x, so the antiderivative of secant squared x is tangent x. Now, since this is asking for the antiderivative, we attach an arbitrary c. Now, that arbitrary c means it could be any constant. So if I were to work backwards to check my work and take the derivative of tan x, I would get secant squared x. And if I were to take the derivative of some arbitrary constant, it just goes away anyway. So what we end up with is c, which means yes in Spanish. Hope this helps. If f of x equals 9x minus 5 plus ln of x, then find f prime of 1. This is asking you to take the derivative, and then once you take the derivative, you plug in 1, see what number you get. Now, got three things going on here. Okay, so f prime is going to be the derivative of 9x, which is just regular power rule, and the derivative of 9x is just 9. Then you have the derivative of negative 5, which disappears, nothing at all. And then you have the derivative of ln of x, which becomes positive 1 over x. So that's what f prime is. Now to complete this problem, we take 1 and plug it in for every x. So 9 plus 1 over 1 is going to be 9 plus 1, which is 10. So if f of x equals 9x minus 5 plus ln of x, then f prime of 1 is 10. The answer is E. Thanks for watching. The graph of the function f is shown below. Which of the following statements is true? So we've got ourselves a crazy looking piecewise function. Lots going on, so we need to find the truth statement here. The limit as x approaches negative 1 of f of x exists. So here's negative 1. In order for the limit to exist at the constant number, the left-handed limit and the right-handed limit have to be the same. This is not the case. The left-handed limit approaches 0, the right-handed limit approaches 1, which means the limit as x approaches negative 1 does not exist. The answer is not A. Let's take a look at B. The limit as x approaches regular 1 exists. Same exact problem. Okay? As the left-handed limit approaches 1, it approaches 1. So that was kind of redundant, but I like what I said. As it approaches 1 from the right side, it approaches 2 as an f of x value. That's not the same. And if you're looking at this point down there and wondering what that means, absolutely nothing in this case. Absolutely nothing at all. So since the left-handed limit and the right-handed limit don't match, that's not going to be it either because it's not going to be true. Let's take a look at C. f of x is differentiable at x equals 2. Differentiable means you're allowed to take the derivative at that point right there. Well, if you have a sharp corner or a cusp, okay, you cannot take the derivative at that point. So since 2 has this sharp corner going on right here, that means 2 is not differentiable, or at least we could say f of x is not differentiable at 2, so C is not a viable option. So lots of lies so far. D says f of x is differentiable at x equals 4. Well, at x equals 4, we have ourselves a constant slope. No cusps, no sharp corners, everything seems to be fine. So this is going to be my true statement because at that moment you are on a continuous, constant slope. So D is true. Now let's just take a look at E because why not? Let's throw an extra minute or two into this problem. The function f is continuous at 1. At 1, you can see that it's broken up into 3 different pieces, so that's definitely not going to be true, so E ain't it. So it's got to be D, which is very similar to what NSYNC said when they said it's got to be me. Or it's going to be me. Oh, crap. Thanks for watching. A particle moves along the x-axis. Cool. The velocity of the particle at time t is given by v of t equals at minus 2t squared, the velocity function. What is the total distance traveled by the particle from time t equals 0 to t equals 4? This is the annoying part about distance problems. Distance and displacement are not the same. Displacement is easy. Distance is not. Like, for example, if I were to go forward like 10 feet, backward like 4 feet, the displacement is 6. The distance is 14. So what we need to do is we need to account for any changes in direction. So what we're going to do is we're going to take the velocity function and find the critical points using the velocity function and pretending that that is already the derivative. So we set u equal to 0. 0 equals 8t minus 2t squared. Let's factor out a 2 and a t, and that gives me 4 minus t, and so my critical points just so happen to be 0 and 4. So I don't have to worry about any changes of direction because any changes of direction would happen at 0 or 4, and my interval is only between 0 and 4, so I don't need to worry about that. That makes life a whole lot easier. So now what I do is, since I have the velocity function, the position function is going to be the integral. So I'm going to integrate 8t minus 2t squared dt between 0 and 4. So the integral of 8t is going to be 4t squared. The integral of negative 2t squared is going to be 2/3 t cubed. And then my limits of integration are going to be 0 and 4. Okay? Now it's just some gross math, so this is not going to be pleasant. Not pleasant at all. That's okay. We're going to have 4 times 4 squared, like so, minus 2/3 times 4 cubed, like so. That's not fun, but this part's going to be kind of easy. 4 times 0 squared minus 2/3 0 cubed. So we all know what's going to happen here. 0 squared times 4 is 0, 0 cubed times blah, blah, 0. This whole thing becomes 0. So now I just need to focus on the left side right there. All right, so 4 times 4 times 4 is going to be 64 minus 2/3 of 64. And I believe, no, that's not going to be pretty at all. I was hoping it would be. Let's turn 64 into something over 3. So that would be 64 times 3 is 192 over 3 minus 128 over 3. And so 92 minus, that's 64/3. Oh, I should have done that. I should have known that. 64/3, which is going to be B. Gross. So not the easiest problem on the planet, but again, yeah, that's how you would do it. It's just this part right here just ended up being nice. That made life a lot easier. So thanks for watching. Given the function y equals ln of x plus 3x squared minus tan x, all taken to the fourth power, what is y prime? Well, this is chain rule. So with chain rule, you are given y equals some type of outside stuff. That's not how you spell outside. That's how you spell outside. And you have some type of inside stuff. And that's what we have here. The outside is 2 to the fourth. The inside is that mess right there. Take the derivative of the outside stuff. Okay, so the outside derivative, keep the inside stuff exactly the way it is, but then multiply everything by the derivative of the inside stuff, like so. So, y prime is going to be equal to the derivative of the outside, which involves me dropping that 4 down out front and subtracting 1 from 4. Keep the inside, so ln of x is still ln of x. Plus 3x squared is 3x squared, and minus tan x is tan x. But then we're going to multiply everything by the derivative of the inside stuff. The derivative of ln of x is 1 over x. The derivative of 3x squared is 6x. The derivative of negative tan x is negative secant squared x. So that would be, let me see, all of these have the 4 out front. You're no good. To the third power, good. Then we have 1 over x, nope. 1 over x plus 6x minus secant squared x. So it's going to be c. I don't like how they're so very similar, but yeah, it's going to be c because we did chain rule. Fun. A tank contains 75 liters of water at time t equals 3 hours. Water is being pumped into the tank at a rate r of t, where r of t is measured in liters per hour and t is measured in hours. Selected values of r of t are given in the table below. So we have t equals 3, 4, 6, and 9, so those are not constant, that's great. And r of t just goes down kind of nicely, that's fine. Using a right Riemann sum with 3 subintervals, what is the approximation of the number of liters of water that are used in the tank at time t equals 9 hours? All right, so let's kind of draw a very, very, very poor picture of what this could look like. Here's 3, right? Here's 4, here's 6, here's 9. Okay, at 3 we're at 10. Okay, at 4 we're at 8. All right, at 6 we're at 7, and at 9 we're at what is that, 6. Right Riemann sums are going to take the right side of the triangle. So we are going to calculate not that one, but that one, and that one. Okay. We're using, now again, if you're wondering like, why not that first one? Well, we start at 3, so really none of this is important. We are going to calculate these 3 rectangles. Now normally what we would do is we would take the change, we would subtract a number, we would divide by 3, but that's not what we're doing here because we kind of have all the numbers that we need. We know that between 3 and 4, you are a length of 1 with a height of 8. So I'm going to use that. Okay, I know between 4 and 6, you are a length of 2 with a height of 7. And between 6 and 9, you are a length of 3 with a height of 6. So I'm going to calculate the 3 areas of these rectangles right here. 1 times 8 plus 2 times 7 plus 3 times 6. Now 8 plus 14 plus 18 is going to be 40. Now if you're like, 40, that's my answer. No. 40 is what we get between 3 and 9. Okay. What we also have is the fact that it already has 75 liters in it. So there's 75 liters plus the 40 that we gain using the right Riemann sums is going to give us 115. So kind of a very tricky problem, a very bizarre problem, not fun at all. Riemann sums aren't everybody's favorite, but that's how I did it. And that's the answer. Fun. Let f be the function defined as follows. We have ourselves a piecewise function. F of x is 2x plus 1, but we only care about that for when x is less than 2. We have just a constant k, which we don't know, for x equals 2, and x minus 2 over x minus 2 for x is greater than 2. So basically, what we need to do is we need to find out what k are going to make these guys continuous. Okay, so for this one, if I were to plug in 2, because keep in mind, we have ourselves a piecewise function, okay? Magic happens at 2. Okay, at 2, I don't know what's going to happen, but I have 2x plus 1, which is going to look like that. It's going to stop right there. I have u, which is going to look like some kind of straight line because it does simplify and cancel out, but even though 2 is against the rules, I don't care about 2 being against the rules. This just ends up being 1. Okay, so whatever that's going to look like, hopefully it looks like that. And then we need to find a k that connects these guys together. But in order for me to do that, I need to find out what happens at 2. So for this first one, if I were to plug in 2, I would get 2 times 2 plus 1, which is 5. And we just determined that this guy down here is 1. So this picture that I drew over here is completely wrong. This is going to happen right there. So how are we going to connect these guys? Well, we can't. There's no number that's going to connect these two. There's no number that's going to make that jump all the way down there, which means no value of k is going to make this continuous at x equals 2. So kind of a tricky problem, but that's how you do it. What is the area of the region in the first quadrant bounded by the graph of y equals e to the 2x and the line x equals 4? Quadrant 1 only. So let's draw quadrant 1 only. E to the 2x looks a little something like this. Okay, so you care about stuff that happens between 0, because it's first quadrant, and 4, because it's that. And so we need to find the area trapped in here. Well, that's just the integral. I mean, if you're thinking about area between curves, that's okay, but that's just the integral. So I'm going to take the integral from 0 to 4 of e to the 2x dx. Now this is going to be integration by u substitution. So let's let u equal 2x, which means du dx is going to be 2. And if I flip-flop the dx and the 2, that ends up making du over 2 equal to dx. So the integral that I can set up now is my limits are 0 to 4, and those are the x values, by the way, not u values, of e to the u du over 2. So let's pull out the 1/2 before I do anything, because there's no need to keep that there. 0 to 4 e to the u du. The integral of e to the u is e to the u, so I have 1/2 times e to the u, where my limits are still 0 and 4, but again, those have to do with x. So now I need to plug the x back in. Since I let u equal 2x, I now have 1/2 e to the 2x, where my limits are 0 and 4. All right, so let's plug those in. 1/2 e to the 2 times 4 minus 1/2 e to the 2 times 0. Which is 1/2 e to the 8th minus 2 times 0 is 1, so 1/2 e to the 1 is 1/2. And what I could do here is I could pull out the 1/2, and I'm left with e to the 8 minus 1, which is going to be b. Find the equation of the line tangent to f of x equals 3x squared minus 8 and x equals 2 in point slope form. So what I have to do is I have to find the slope, which is f prime of x. That's going to give me slope. So let's find f prime of x, shall we? F prime of x is going to be dropped down to 2, 6x minus 8 just disappears. Now at x equals 2, the slope at that moment right there is going to be f prime of 2, which is going to be 6 times 2, which is 12. So my slope is 12. Now, I'm given the x value. If I'm thinking point slope form, I'm like, oh cool, I have a slope, but I only have half a point. So I need the other part of the point, which is found by me taking 2 and plugging that into the original f function. So 3 times 2 squared minus 8 is going to be 3 times 4 minus 8, which is going to be 12 minus 8, which is going to be regular old 4. So if I have a slope of 12, and now I have a point of 2, 4, I have enough information to make point slope form. So point slope form is y minus y sub 1 equals m times the quantity x minus x sub 1. You would be my m, you would be my x sub 1, you would be my y sub 1. So all I have to do is just plug stuff in. Y minus y sub 1 is y minus 4 equals m, which is 12, times the quantity x minus x sub 1, which is 2. And that's going to be A, baby. All right. A. Okay. Evaluate the integral of e to the x squared times 2x. Well, in a problem like this, since it's obviously going to be integration by u substitution, we want to choose a u such that we see its derivative floating around somewhere in the problem. The derivative of x squared happens to be 2x, so I'm going to let u equal x squared, which means du dx is going to equal 2x. And if I flip-flop the dx and the 2x, I get du over 2x equals dx. So now I can rewrite this. Now I can rewrite that over here as the integral of e to the u, since I let u equal x squared, e to the u, times 2x, and instead of dx, du over 2x. And just like that, the 2x and the 2x cancel each other out, leaving us with the indefinite integral e to the u du, which is going to be e to the u plus c. And the last step is replacing u with x squared, so e to the x squared plus c, which is going to be a. Not bad. Let f of x equal x squared minus 3x minus 1 and g of x equals 2x plus 1. What is f prime of g of negative 2? Well, let's start out by finding out g of negative 2. G of negative 2 is going to be 2 times negative 2 plus 1, which is going to be negative 4 plus 1, which is going to be negative 3. Now that I have that, I can find f prime of negative 3. So f prime of x is going to be 2x minus 3, because power rule and power rule. So f prime of negative 3 is going to be 2 times negative 3 minus 3, which is negative 6 minus 3, which is negative 9. And that's your guy. Use the graph of f of x below to calculate the integral from 0 to 12 of f of x dx. So again, what is the value of the integral from 0 to 12 of f of x dx? So basically, I'm not given the actual formula. I'm given a picture. Now remember, the integral from whatever to whatever is the area under the curve. So I'm looking at this and I'm noticing, wait a minute, I have 3 shapes. I have that shape right there, like a triangle, a nice perfect looking triangle. I have that shape right there, a nice perfect rectangle, and I have that shape right there, a nice right trapezoid. So let's focus on the triangle first. Okay, this is a triangle that has a base of 5 and a height of 5. Okay, so the area of a triangle is half times base times height. So in this case, half times 5 times 5, which is going to be half of 25, that's a 5, which is going to be 12 and a half. All right, cool, I can handle that. This second shape is going to be a rectangle with a height of 5 and a length of 3. So the area of that is a rectangle, which is length times width. So 3 times 5, which is 15. Much more manageable. This last guy is a right trapezoid with a height of 5 over here, and then technically a base of 5 over here. We have a height of 4, and a second base that goes up to 7. So the area of a trapezoid is I guess we could say 1/2 of the height times base sub 1 plus base sub 2. Okay, So 1/2 of the height, which is 4, times base sub 1, which is 5, plus base sub 2, which is 7, which is 1/2 of 4 times 12, which is 2 times 12, which is 24. So we take those three numbers, 12.5, 15, 24, we add them all up, that'll get us 51.5, and 51.5 is C. Pretty easy. Given the function h of x equals 4 cos quarter pi x minus 1, which of the following statements is true regarding h of 6, h prime of 6, and h double prime of 6? All right, so we got to figure out each one of these guys and see what we get here. So let's take a look at h of 6. h of 6 is simply saying, what is the value when you were to go over to 6 and plug it in? Well, it looks like h of 6 is going to be -1. So you get that point right there. H of 6 is going to be -1. Cool beans. H prime of 6 is the slope at 6. So we go over to 6, and it looks like right around here, it looks like the slope is probably like 2-ish. So we'll say that h prime of 6 is going to be 2-ish. We don't know the absolute number, but it's going to be somewhere in that area. It's kind of steep. Maybe it's like 1.5 or something. I don't know. I'm going to go with 2-ish right there. Okay. Now, h double prime of 6 has to do with concavity. And in this case, if I were to put a dot there, it looks like there's a change in concavity, which means you are an inflection point. So h double prime of 6, since it's an inflection point, is 0. That's where concavity changes. So what I have is I have h of 6 is definitely negative, h prime of 6 is definitely positive, and h double prime of 6 is 0. So the smallest of these is h of 6, and then right in the middle is h double prime of 6, and then after that is h regular prime of 6, which is going to be B. The position of a particle is given by the equation S of t equals at squared plus bt, where a and 0, a and b are not the same. When is the particle at rest? Well, the particle is at rest when the velocity is equal to 0. Now we find the velocity by taking the derivative of the position function. So we want to know when the derivative of that guy is equal to 0. So let's take the derivative of that guy with respect to t. Now we don't have regular numbers, we have a and b. Okay, where neither of those guys are 0. So if I were to take s prime of t, the derivative of at squared has me dropping the 2 down, leaving a there, and then t squared becomes t. The derivative of bt is just going to be b. Now, if I were to take that and set that equal to 0 and solve it for t, it's just basically a literal equation. Okay, so we would subtract b from both sides like this. So negative b equals 2at. Divide both sides by 2a. Divide both sides by 2a. And t is going to equal negative b over 2a, which looks like u. So a weird problem, a strange problem, but not that bad. Given that f of x is the integral from 2 to x of g of t dt, and the graph of f of x is a linear equation with a positive slope passing through the x-axis, what could be the graph of y equals g of x? All right, f of x is linear with a positive slope. That's very important. So if it's linear with a positive slope, it could look something like y, I shouldn't call it y, I should call it f of x equals, I'm just giving examples here, something like f of x equals 3x plus 2. Or f of x equals 10x minus 5, whatever. I'm just making stuff up. But What I do know is if I'm given this information right here and I need to find g of t, f prime of x, taking the derivative of both of these gives me g of t. The derivative of the integral gives me g of t. So I have to take the derivative of both sides here. So f prime of x is going to get me regular g of t, which is what I want. Okay, now yes, it says g of x, but after you integrate and then take the derivative, it becomes g of x, which is awesome, which is fine. Taking the derivative of any of these guys is just going to leave me with a positive integer. Like taking the derivative of f of x here would be 3. So like f prime would be 3. Or f prime would be 10 in this case. F prime of any linear equation with a positive slope is just going to be a positive number. So the graph is always going to look like a positive constant number, which is going to be something that looks like this, which is a horizontal line above the x-axis. So kind of a tricky problem, but yeah, that's how you do it. Find the value of the following limit. So you're given the limit as h approaches 0 of ln of 5 plus h minus ln of 5 all over h. Well, if you're wondering, boy oh boy, this looks a lot like this guy. The limit as h approaches 0 of f of x plus h minus f of x all over h. You're absolutely right. That's the derivative by limit formula. So you're basically comparing these two. And in a sense, if you notice this guy right here, ln of 5 and f of x, that means f of x is ln of x at x equals 5. So that's what we're trying to do. We are trying to find the derivative as x approaches 5. Not as x approaches 5, but when x is 5. So let's take the derivative of ln of x. So f prime of x is going to be 1 over x. Let's plug in 5. F prime of 5 is 1 over 5. And that's our guy. So not a difficult problem, just the way it's worded made it seem a whole lot worse than it had to be. For the function f of x equals x minus 2 over x plus 2, find the x values where the slope of the tangent to the curve is 1/4. Well, the slope of the tangent to the curve means f prime of x. That's the derivative. And we want to find out when f prime of x is equal to 1/4. So we need to find the derivative of that guy, which involves quotient rule. So quotient rule is u prime v minus v prime u over v squared. I know a lot of teachers might do the high d low and the f's and g's and stuff like that, but I just do it this way. U is the numerator, so x minus 2. V is the denominator, so x plus 2, which means u prime is going to be the derivative of u, which is 1, and v prime is going to be the derivative of v, which is also 1. But v squared is going to be x plus 2 in parentheses squared, which I'll probably have to multiply out at some point, but we'll worry about that when we have to worry about that. All right, so let's put it all together. F prime of x is going to be u prime v, so 1 times x plus 2 minus v prime u, so 1 times x minus 2 over x plus 2 squared, and that's going to equal 1/4. Okay, the derivative equals 1/4 in this problem. That's the point. That's what we're solving for. All right, so multiplying 1 to everything is just going to be x plus 2, no loss of sleep over that. Negative 1 to everything is going to be minus x plus 2. And then multiplying all of this out is going to be x squared plus 4x plus 4 because perfect square trinomials. That's going to equal 1/4 again. All right, and last time I checked, 2 plus 2 is 4. And so you can stay x squared plus 4x plus 4 equals 1/4. Now what we could do is cross multiply. So 1 times u isn't going to change anything. So x squared plus 4x plus 4. 4 times 4 is 16, so equals 16. Let's subtract 16 from both sides. So that gives us x squared plus 4x minus 12 equals 0. That should factor out nicely to x minus 6, nope, x plus 6, x minus 2 equals 0, which means our magic numbers are going to be x equals negative 6, x equals positive 2. That's how you do it. Let f of x equals parentheses 4x minus 5 close it square it, and let g be the inverse function of f. Given that f of 0 is 1, what is the value of g prime of 1? Well, if we're talking about inverses and its derivatives, we have a little formula that says that g prime of x is going to equal 1 over f prime of g of x. Like so. All right, so since f and g are inverses, it says it right there, since f and g are inverses, and we are told that f of 0 is 1, that would mean to flip it around for inverse stuff, g of 1 would equal 0. So, in order to find g prime of 1, we start out by saying f prime of g of 1, right? And so that g of 1 inside the parentheses, g prime of 1, is going to be 1 over f prime of 0. So now what we need to do is find out what f prime is. So let's go off to the side and do that so I don't have to worry about thinking, all this fraction grossness. F prime of x is parentheses 4x minus 5 close it square it. Now you could FOIL that out, but I'm going to just use chain rule because I'm going to end up plugging in 1 anyway, or 0, I'm sorry. I'm going to end up plugging in 0 anyway. So chain rule has me drop the 2 down, take the derivative of the outside, which means drop the 2 down. The derivative of the outside makes it look like that. 2 becomes invisible 1. Keep the inside, but then multiply everything by the derivative of the inside. The derivative of the inside would be 4. So f prime of x becomes 8 times 4x minus 5. Now f prime of 0 is going to be 8 times 4 times 0 minus 5, or 8 times negative 5, which is negative 40. So f prime of 0 is negative 40. So g prime of 1 is 1 over negative 40. And that's u. Isn't that neat? The line y equals 3 is a horizontal asymptote to the graph of which of the following functions. Now, those of you who know my expertise, it's AP Pre-Calculus. And we are taught that if I have something where you have the same degree over the same degree, like for example, something like 3x to the 4th plus blah, blah, blah over x to the 4th plus blah, blah, blah. If you have something like that, if the degree on the numerator is the same as the degree in the denominator, you take the leading coefficients, so 3, invisible 1, and your horizontal asymptote is going to exist at the leading coefficients over the leading coefficients as long as the degree is over the degree. So what I want to look for is something that has the same degree over the same degree, where the leading coefficient up here is 3 and the leading coefficient down here is 1, and that way I'll get the horizontal asymptote at 3. Does that happen here? No. Okay, this gives you a horizontal asymptote at 0 because the denominator has a larger degree. You're not going to work out. You're a linear equation, which means you're not even going to have a horizontal asymptote. Okay, you're sine of 3x, which means you look like that, so you're not going to have a horizontal asymptote. You're a linear equation. It's going to look something like this. You don't have a horizontal asymptote. You have 9x squared up here and 3x squared down there. So the degrees in the numerator are the same as the degrees in the denominator. So you focus on the leading coefficient over the leading coefficient, which is 9 over 3. That divides out to 3, which means your horizontal asymptote exists at y equals 3. And that's how you do that one. Let f of x equals negative 3x squared plus 6x minus 5. What is the absolute maximum value of f of x? Well, in order to find the absolute maximum value, we have to find its critical points. Critical points will tell us whether or not we have a maximum or a minimum, and then we can go from there. So how do you find critical points? Well, you take f prime of x and then set it equal to 0. So f prime of x is going to be the derivative of u, so negative 6x plus 6 plus 0. So set u equal to 0, like so. Subtract 6 from both sides. Negative 6 equals negative 6x. Divide both sides by negative 6. Divide both sides by negative 6, and positive 1 equals x. So the critical point is going to be 1. Now, what a critical point does is it tells you where your slope is 0. So if your slope is 0, that means you're going to either have a maximum, because our slope is 0, or a minimum, as long as there's a sign change. So we're going to make a sign table and make sure that there is a sign change. So at 1, we have a critical point. This is the sign table for f prime of x. So what I need to do is, since I only have one critical point, I have an interval of negative infinity all the way up until 1, and then from 1 all the way up until infinity. So I'm going to take a number like 0 and plug it into f prime of x and see if I get a positive or negative number. If it's positive, that means my function f of x is increasing. If it's negative, that means my function f of x is decreasing. I'll also plug in 2, because that's some number in the interval from 1 to infinity. So f prime of 0 would be me taking that equation right there and saying negative 6 times 0 plus 6 is going to be 0 plus 6, which is a positive number. So you're positive, which means you are increasing. F of x is increasing. Now we do it again. F prime of 2 is negative 6 times 2 plus 6, which is negative 12 plus 6, which is a negative number. So what's happening here is f of x is increasing, but once it hits x equals 1, it hits a peak up here and then starts decreasing. So we definitely do have a maximum. Okay, I just wanted to make sure of that. We definitely do have a maximum value at x equals 1. In order to find out what that maximum value is, you plug 1 into the original equation, not the derivative, because the derivative will give you 0. You plug it into the original equation because that tells you where it exists on the original function f of x. So regular f of 1 is going to equal negative 3 times 1 squared plus 6 times 1 minus 5. So negative 3 times 1 squared is going to be negative 3 times 1. 6 times 1 is going to be 6 minus 5. Negative 3 plus 6 is regular 3. 3 minus 5 is going to be negative 2. So our maximum value is going to happen at the point 1, negative 2. And so the answer is C. All right, get ready for a pretty easy question, but it's potentially confusing, and so a lot of people get this wrong. If P of t represents the size of a population at time t, which of the following differential equations describes linear growth in the size of a population? A linear equation is in the form y equals mx plus b, where m can be any number as long, in this case, as it's not 0, right? B can be 0, who cares? Which means if P of t is supposed to be linear growth, right? And so linear growth also means that m in this case has to be greater than 0. We are looking at something where P of t has to be in the form m times, and we won't use x, we'll use t, plus b. And in the same vein, m has to be greater than 0. Okay, so that's linear growth, which means in order to take the derivative of that, okay, we would get the derivative, which is dp dt, is going to equal the derivative of m times t is just going to be m, and then the b disappears because, a constant just goes away. So the derivative is just going to be some integer greater than 0, like 5. Okay? So again, you're looking for P of t being linear growth, which means it's got to be in the form y equals mx plus b. So when you take the derivative of it, you end up with just a regular constant that is a positive number, which is why this is the one that works. I think a lot of people would look at this one and circle that one immediately thinking, oh, well, that's linear, like y equals mx plus b. No, sir, no, ma'am, that's not how it works. Let g of x equals x times e to the kx, where k is a constant. For what value of k does g of x have a critical point at x equals 1? All right, so critical points exist when g prime of x is going to be equal to 0. So that's what we need to deal with first. Since g of x is x times e to the kx, this is going to involve product rule. Product rule is u prime v plus v prime u. So what I need to do is find out if I label u as x and if I label v as e to the kx, u would be x, v would be e to the kx, right? U prime is 1. V prime is going to be, take the derivative of the outside stuff, which is still just e because the derivative of e to the whatever is e to the whatever. Keep the inside, which is kx. But since k is a constant, multiplying everything by the derivative of the inside would be me like taking the derivative of 2x or 4x, which is 2 or 4, or in this case, k. So now, g prime of x is going to equal u prime v, so 1 times e to the kx, plus v prime, so k, e to the kx, times u, which is x. So let's clean this up a bit. E to the kx plus kx e to the kx. Now, g prime of 1 has me substituting 1 for every x. So e to the k times 1 plus k times 1 e to the k times 1. So e to the k plus k e to the k. Now I want to set g prime of x, or now g prime of 1, equal to 0. So let's set u equal to 0. I have an e to the k in common with both. Okay, so let's factor out an e to the k, and that leaves me with 1 plus k. Now you use the zero product property and set this up as two separate equations, all right? E to the k equals 0, and 1 plus k equals 0. Well, what value of k, if I were to use it as an exponent, would get me 0? Nothing. This is exponential. There's no number that will, if I were to plug into k, would get me 0. It's impossible, so you're an impossibility. This guy, all I have to do is just subtract 1 from both sides, and k equals -1, which is going to give me b. So a very, very, very bizarre problem. Very bizarre problem, but that's how you would do it. Solve the differential equation dy dx equals 4 cos x with the initial condition y of 0 equals 4. What is the solution? Well, if I want to get the solution, if I want to get y of x, what I'm going to do is integrate both sides here, because the integral of a derivative gets it back to its original function. So this would give me y of x. So y of x is going to equal the derivative, or I'm sorry, the integral of 4 cosine x dx. Okay? Now the integral of 4 is just 4. The integral of cosine is sine x, no negatives to worry about. But since this is an indefinite integral, I have to attach plus c there. All right, so y of x equals 4 sine x plus c. What do I know? Well, it tells me right here that y of 0 is 4. Here's y of x. So if I want to find out what c is, I'm going to replace x with 0. So 4 times sine of 0 plus c. Okay, sine looks like this. So sine of 0 is 0. So y of 0 is going to equal 4 times 0 plus c. And by the way, y of 0 is 4, so 4 is going to equal 0 plus c. So c is 4. So taking this guy right here and this little piece of information right here, we can come up with the equation y of x equals 4 sine x plus 4, which is u. Let g of x be a function with the first derivative given by g prime of x is the integral between 0 and x of e to the negative 4t dt. What is true about the increasing, decreasing behavior and concavity of g of x on the interval between 0 and 2? All right, well, generally speaking, okay, e to the negative 4t is going to be exponential decay. Looks something like this, right? Of course, the picture that I drew is awful, but what will happen is this guy will never, ever, 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 ever touch the x-axis. So what we're basically saying is the derivative, or at least this guy, is always going to be positive. Now, if the derivative is always positive, that means g of x is always increasing, okay? So since this is always positive, that means the integral, the area underneath the curve between 0 and whatever x, is also going to be positive, okay? And if the integral is positive too, that means g of x is increasing between 0 and 2, okay? So it's going to be increasing, which means nope, nope, and nope. Now we need to take a look at concavity. Concavity exists at g double prime of x. Okay, so if I were to take the derivative, so let me just kind of draw this out. G prime of x is equal to the integral between 0 of x e to the negative 4t dt. If I were to ddx both sides, or yeah, it would be ddxing both sides, right? That would be me finding the second derivative. Now what that would do is that would give me g double prime of x, and the derivative of the integral kind of just cancels each other out. So g double prime of x is just e to the negative 4x, which reverts back to this picture right here. Now that picture, even though the picture is drawn poorly, sure looks like the left side of concave up, doesn't it? Sure looks like the left side of concave up. So we can say that this is concave up. So since g of x is increasing and g of x is concave up, we could say that my answer is going to be B for this one. So very tricky problem, and this is towards the end of the multiple choice section of these guys. You're going to start running into weird problems. This is one of them. Not fun, but we did it. Oh boy, this one's going to take a minute. Given the equation x squared plus 2xy equals y squared, determine the value of the second derivative at the point 2, negative 1. So this is implicit differentiation. So we're going to ddx both sides. We're going to ddx x squared plus 2xy equals the ddx of y squared. Remember, when you take the derivative of an x, no big deal. Take the derivative of your x. If you have to take the derivative of the y, you take the derivative but attach a dy dx or a y prime. I'm going to use y prime. This guy right here is product rule. 2x times y is product rule. So I'm going to let u equal 2x. I'm going to let v equal y. U prime is going to be 2. And v prime is going to be the derivative of y with respect to x, which is dy dx, or just y prime. So the product rule is u prime v, so 2 times y, so plus 2y, plus v prime u, which is going to be y prime 2x. And I know I'm writing that out of order, but I want to write it out so that the y prime is next, or second, I guess. Now, let's move you to the other side, like so. And so the left side is now 2x plus 2y equals 2y y prime, 2y y prime minus 2x y prime. Factor out whatever you can on both sides. Factor out a 2 on the left, 2 times x plus y. Factor out a 2 and a y prime on the right. And that gets us y minus x. Divide both sides by 2. Divide both sides by y minus x. And y prime is going to be x plus y over y minus x. That's the first derivative. Now on to the second derivative, which requires me to do quotient rule. U is x plus y, v is y minus x, u prime is the derivative of the top, so the derivative of x is 1, the derivative of y with respect to x is y prime. V prime is going to be the derivative of the bottom. The derivative with respect to x of y is y prime, minus x is 1. And then v squared is going to equal y minus x squared. Let's see if we have to deal with that when we have to deal with that. Probably not, but we'll see. We'll see. All right. Quotient rule is u prime v minus v prime u over v squared. So let's go up here. Oh boy, I'm so scared that I'm going to run out of space. Sloppy. All right, u prime v, so y double prime is going to equal u prime v, so u prime is 1 plus y prime, v is y minus x, minus v prime, which is y prime minus 1, u, which is x plus y, over y minus x squared. Let's simplify that. Y double prime, let's do some foiling, is going to be 1 times y is y minus x plus y prime y minus xy prime. So not only, minus parentheses, gross, xy prime plus yy prime minus x minus y. And that's still all over y minus x squared. Let's distribute that negative. Y double prime is going to equal y minus x plus y prime minus xy prime minus xy prime. How nice. Minus y prime. How nice. Minus plus x plus y. So lots of stuff here disappears. All right, let's, oh, by the way, I forgot to write out over that. Again, I'm not changing u, not yet. Okay, so let's see what disappears. We've got the y's unfortunately combined, so u will become 2y up top. The x's disappear. The y primes disappear, and you become minus 2xy prime over y minus x squared. Now we know that y prime from over here is this. So you become 2y minus 2x times x plus y over y minus x all over y minus x squared. Now would be a good time to finally plug in that point right there. All right, so y double prime at that point is going to be 2 times negative 1 minus 2 times 2, parentheses, 2 plus negative 1 over negative 1 minus 2, all over negative 1 minus 2 squared. Oh boy, I'm scared. Negative 2 minus 4, 1 over negative 3, so negative 1/3. And that's going to be over negative 1 minus 2, all of which is squared, so negative 3 is squared, so 9. So we've got negative 2 plus 4/3 over 9, which is negative 2/3 over 9, which means we multiply the top and the bottom by 1/3, so negative 2 over 27. Oh, thank you, Lord Jesus. Okay, whew. That was a nightmare. That was an absolute nightmare. And that took up a ton of space. But somehow we were able to do it, and thank you for bearing with me. That was gross. For t is greater than or equal to 0, which means time is greater than or equal to 0, the position of a particle moving along the x-axis is given by x of t equals cos t minus sine t. What is the acceleration of the particle at the point where the velocity is first equal to 0? All right, so this is the position function. So the velocity function is going to be the derivative of that. So x prime t is going to be the derivative of cos t, which is negative sine t, minus the derivative of sine t, which is cos t. Why I put that in parentheses and I didn't put that in parentheses, I don't know. But that is, so I have my velocity function. I care about when the velocity function is first equal to 0. So let's set that equal to 0. And so 0 now equals negative sine t minus cos t. Let's add cosine to both sides. So plus cos t, and we have cos t equals negative sine t. Let's divide both sides by cosine t to make it a tangent. So cosine t divided by cosine t, that's going to become 1, is equal to negative tangent t, which means tangent t is negative 1. All right, let me see if I can just give myself a little bit more space over here. You'll see why in a second. All right. Inverse tan both sides. Inverse tan both sides. And the inverse tangent of negative 1, think of it this way. Tangent means slope. So negative 1 is going to look like that. And so if you're thinking unit circle thoughts, right, it's going to first hit the negative 1 right there between pi over 2 and pi, which is 3/4 of a pi. So t is going to be 3/4 of a pi. Why would I put 0 down there? 3/4 of a pi. All right, so that's my t, which means gossip in slang. What is the acceleration of the particle at that point? So now I have t. I need to find the acceleration. The acceleration is the second derivative. So acceleration, right, is the second derivative. So x double prime of t, which is going to be the derivative of negative sine t, which is negative cos t, minus the derivative of cos t, which is positive sine t. So what I want to do is I want to plug in 3 pi over 4. So x double prime of 3 pi over 4 equals negative cosine of 3 pi over 4, unit circle thoughts, plus sine of 3 pi over 4. So we're looking at lots of root 2's and stuff. So u will become negative, and again, we're over here, so negative, cosine's the x value, negative root 2 over 2, plus sine is the y value, so that's going to be regular root 2 over 2. So the double negatives cancel out to become root 2 over 2, plus root 2 over 2. Root 2 plus root 2 is 2 of them, so 2 root 2 over 2 crosses out root 2. Bing, bing, bong. And just like that, we're done. So that ends the multiple choice, no calculator section of the GOAT exam. On to the calculator stuff.